Today we're going to be going over how to wire a circuit, and before we can get into the circuit I have to go over some basic symbols. This symbol represents a voltmeter. A voltmeter has two terminals, a positive terminal, as you see in red, and a negative terminal, as you see in black. The two colors correspond to the ports that are actually on the voltmeter in the lab. This symbol represents an ammeter. It too has two terminals, a positive terminal, shown in red, and a negative terminal, shown in black. The color of these terminals also reflect the color of the terminals on the ammeter. The red terminal is the 100 milliamp terminal that you'll be using in your lab, where the minus or black terminal will represent the COM port on the ammeter. This symbol represents a DC power supply. The plus terminal in red corresponds to the red terminal on the power supply. The minus symbol in black corresponds to the black terminal on the DC power supply. This symbol is a resistor. It also can be referred to as an impedance. Now that we covered the various symbols of our circuit, let's wire the circuit up. We're going to put the circuit together. Here's a simple circuit composing the components that you were looking at. First, the resistor and the power supply. Next, we're going to insert an ammeter. The ammeter goes in series between the power supply and the resistor. The current will leave the power supply through the ammeter to the resistor. If the ammeter reads a positive value, then the current direction is what we anticipated. If not, if it receives a negative value, then the current direction is in the opposite direction than we anticipated. Take note of this. Next, we want to measure the voltage across the resistor, so we add the voltmeter. When measuring voltage, we put voltmeters in parallel to the device we're measuring the voltage across. Okay, today we're going to go over that circuit that we've been looking at and pointing out the various components. We've gone over the symbols, the power supply, the ammeter, the resistor, and the voltmeter. We're going to set the voltage on our power supply to 10 volts. Powering it up, you can see that we're going to adjust using the B1 terminals, and I've adjusted the voltage already to be close enough to be about 10 volts. I'm going to power it off, and the reason being is when you throw out your circuit, when you're wiring it, when we've plugged one side of our power supply in, that terminal there is now live. So by powering the power supply off before we continue our circuit, we're just guaranteeing you're not touching any live wires. So let's look at just this loop here for the time being. I'm going to connect my power supply from the positive terminal to the positive terminal of my ammeter. In our lab we have two Fluke 45 dual display multimeters. We'll use one, this one here, as my ammeter, and this one here as my voltmeter. So let's hook up this circuit first. So from my power supply, which is turned off, I'm going to connect to the 100 milliamp terminal, not the 10, but the 100 milliamp terminal. We can power on our meter. And we're going to select the ammeter button with a solid line and a dashed line below it. You'll see at this point, you'll see that milliamp DC. We know we're actually using an ammeter. Now, from the negative side of my ammeter, which is also the common, we're going to connect one side of our resistor, the 10K resistor. Now, I've connected from here to here, from here to here. We've got our 10K resistor. Now let's connect up the other side of our 10K resistor to our power supply. So we've now connected this entire loop. Now let's connect our voltmeter. First of all, we power up our voltmeter. I'm going to connect on the V side with our banana jack. I'm going to connect it to the top connection of the resistor. And from the common side of the voltmeter, I'm connecting to the other side of the resistor. Again, here we're going to be selecting volt DC. By default, it was started there. And you'll see millivolt DC, we know where I got that set up as a voltmeter. Now, step back, look at the circuit, and ensure that everything looks fine. You may have to call your TA over to make sure that you've connected the circuit right. And once you've got the clear, power up our power supply. We can see at this point we're having our 10 volts going across our resistor. I can see here that I have 1 milliamp passing through the resistor. And I can also see the 10 volts being reflected across the resistor.